Dear students, under the lecture series on the topic graph theory, here we have lecture 11. We are going to prove a theorem under the topic operations under graphs. Now here the theorem says that if G1 and G2 are two graphs where the number of vertices and the number of edges of graph G1 is P1 and Q1, and the number of vertices and the number of edges of graph G2 is P2 and Q2, and so they are known as P1, Q1 graph, and G2 is known as P2, Q2 graph. We have to prove these following four subdivisions. That is, if G1 and G2 are two graphs, then G1 union G2 is a graph with number of vertices to be equal to P1 plus P2 and the number of edges to be equal to Q1 plus Q2. In a similar way, we have other operations also. This is union, this is sum of two graphs, this is product of two graphs. In fact, we can say that as Cartesian product, and this represents the composition of two graphs. So we shall prove each subdivision one by one along with illustration. First of all, we shall consider graph G1, and let us take the vertex set of G1 as V of G1 and the edge set of G1 as E of G1. So after taking this, it is given that the number of vertices for G1 is P1. So from this we can write as the cardinality, that is the modulus of V of G1, represents the number of vertices of the graph G1, and it is given as P1. And the number of edges of the graph G1 is equal to, here it is given as Q1. In a similar way, we have the same for graph G2. So that also we have written. So therefore, the number of vertices of G2 is P2 and the number of edges for G2 is Q2. Now here the first subdivision is we have to prove that G1 union G2 is a P1 plus P2, Q1 plus Q2 graph, which means that we have to prove that G1 union G2 has the number of vertices to be equal to P1 plus P2, that is the number of points, and the number of lines, that is the edges, to be equal to Q1 plus Q2. So let us prove this now. Now before diving into the direct proof of this, we shall check this with the help of an example. So we will consider two graphs G1 and G2. So for example, if we have graph G1, so we are just going to take it as this. So here we are going to take this point as U1 and this point as V1. So this is graph G1. And we are going to take another graph G2. And how are we going to take that? Let us just consider some other graph. So this is G2. And let us take this point as U2, this as V2, and this as W2. Now, if we observe that how many points do we have in graph G1? So the number of points is represented as P1 for G1. It is equal to, we have 2 points. And how many lines do we have? That is Q1 is equal to, we have only one line. So we can write it as 1. Now for graph G2, how many points we have? If we check 1, 2, 3. So 3 points. And how many lines we have? Lines are represented as Q2 for G2. We have 2 lines, 1, 2. So now we will take the union of this, that is G1 union G2. And how that graph will be? Combining, that is we will take both G1 and G2, and this will give us G1 union G2. So in a graph G1 union G2, we have G1 as well as G2. So that is only union as per the definition. And points also remain the same. So this is U1, V1, this is U2, V2 and W2. Now this we have to take as a whole as one graph. So now if you take in that way, how many points it has? It has 1, 2, 3, 4, 5. So the number of points is 5. So the number of points is 5. And number of lines, if you check, it will be equal to 1, 2, 3. So 3 lines we have. Now, as per this theorem, we have to prove that it has P1 plus P2 points and Q1 plus Q2 lines. So, what is P1 plus P2? So, if we check, P1 is 2 and P2 is 3. So, P1 plus P2 is 2 plus 3, which is equal to 5. And what is Q1 plus Q2? It is equal to Q1 is 1 plus Q2 is 2, and that is equal to 3. We see that number of points is equal to P1 plus P2, which is 5. So both are same. In a similar way, the number of lines is equal to 3 for this graph, and when we checked Q1 plus Q2, it was also equal to 3. So with the help of this illustration, we have proved this theorem. Now we shall see the theoretical proof for this. So by the definition of union of graphs, we know that the vertex set of the union of two graphs G1 and G2 will be equal to vertex set of G1 union vertex set of G2. So we have to take the vertex set of these two graphs, and if we take the union, it will be equal to the vertex set of G1 union G2. So from this we can say that the cardinality of vertex set of G1 union G2, that is the number of points, will be equal to the number of points of the graph G1 plus the number of points of the graph G2. So we have to add them. And we know that the number of points for graph G1 is P1 plus the number of points for graph G2 is P2. Therefore, we have proved that the number of points for G1 union G2 is equal to P1 plus P2. Also, we know that the edge set of the graph G1 union G2 will be equal to the union of edge set of G1 with the edge set of G2. And from this, we can say that the cardinality of G1 union G2, that is the number of lines of G1 union G2, will be equal to the number of lines of G1 plus the number of lines of G2. And what are the number of lines of G1? We know that it is Q1. And the number of lines for G2 is Q2, and therefore it is equal to Q1 plus Q2. Hence, we have proved that the number of points for G1 union G2 is P1 plus P2, and the number of lines for G1 union G2 is Q1 plus Q2, and therefore we can say that the graph G1 union G2 is a P1 plus P2, Q1 plus Q2 graph. Since it has P1 plus P2 number of points and Q1 plus Q2 number of lines. So we have proved the first subdivision. So we are done with the first subdivision. Now let us see the second subdivision. So this is done. Now what is the second subdivision? It says that the sum of two graphs G1 plus G2 is a P1 plus P2, Q1 plus Q2 plus P1 P2 graph, which means that the number of points for G1 plus G2 is P1 plus P2, and the number of lines for G1 plus G2 is Q1 plus Q2 plus P1 P2. So we have to prove this. So let us do that. So this is what we have to prove. We have to prove that G1 plus G2 has P1 plus P2 points and Q1 plus Q2 plus P1 P2 lines. So now in order to prove this, first we should understand what is the sum. What does the definition of sum say for sum of two graphs G1 plus G2? So by the definition we know that, by definition the sum G1 plus G2 is same as G1 union G2. So this we have to do first. And along with this, together with all the lines joining points of vertices of G1 to the points of vertices of G2. So I will illustrate this with the help of an example. We will take the same graph G1 and G2 that we took for subdivision 1. So now I have taken the graph G1 and the graph G2. Now we shall find G1 plus G2. So G1 plus G2. As I told you in this definition, first you have to find G1 union G2. What is that? It is simply the two graphs we have to write like this. So G1 G2 with this as V1 U1 V1 U2, V2, W2. After that, along with this, together with all the lines joining the points of vertices of G1 to the points of the vertices of G2. So all the vertices of G1 has to be joined to all the vertices of G2. So for example, if we take this point, it has to be joined to all the vertices of G2. Similarly, if you take this point, it has to be joined to all the vertices of G2. It's like complete bipartite graph which we will do. But before that, we have the condition G1 union G2. Along with that, this bipartite condition also we have. So this graph is known as G1 plus G2. Now we know that for this graph, P1 is equal to 2 and Q1 is equal to 1. And for this graph, P2 is equal to 3 and Q2 is equal to 2. Now what about G1 plus G2? How many points it has, that we have to check. It has 1, 2, 3, 4, 5. So 5 points it has. And how many lines it has? It has 1, 2, 3, 4, 5. So 5 lines. So let us check the condition. So we have to prove that it has P1 plus P2 points, right? So what is P1 plus P2? So if we check, P1 is 2 and P2 is 3. So 2 plus 3, which is equal to 5. Therefore, it has 5 points. This we are getting correctly. In a similar way, how many lines it should have? So we have to prove that it has Q1 plus Q2 plus P1 P2 lines. So what is Q1 plus Q2 plus P1 P2? It's equal to Q1 is what? 1 plus Q2 is 2. So this is Q1 Q2 plus P1 P2. P1 is 2. We have to multiply this with P2, which is 3. So if we check now, it will be 1 plus 2 plus 3. 2 times is 6. Okay. And that will be equal to 6, 7, 8 and 9. Actually, I have written 5 here. I counted only, I didn't count the lines properly. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it actually has 9 lines. So by mistake I wrote 5. So it is 9. So therefore we check that these two are same. So these are the 9 lines of the graph G1 plus G2. So this illustration proves the second subdivision. But let us see the theoretical proof now. So now by the definition, what do we have? The sum G1 and G2 is G1 union G2 together with all the lines joining vertices of G1 plus vertices of G2. And we see that this talks about only lines. So the vertex set of G1 plus G2 will be equal to the vertex set of G1 union G2. So let us write that. So we have written that, but we know that the vertex set of G1 union G2 from subdivision, we know that it is equal to P1 plus P2. So therefore the vertex set of G1 plus G2 is equal to P1 plus P2, which implies G1 plus G2 has P1 plus P2 number of points. So we have proved about the points. Now next we have to prove about the edges. So what about the edges? Now the edges will be modulus of edge set of G1 plus G2 will be equal to the edge set of G1 union G2. So this is one thing. Together with, so plus the edge set of, so modulus of, actually what is that? It is together with all the lines joining points of V of G1 to the points of V of G2. But I told you it is same like the bipartite condition. So how it is? It is like a complete bipartite graph K with one of this part has 2 vertices and the other part has 3 vertices. And we know that the bipartite graph K with such, that is P1 comma P2 vertices will be equal to, the number of vertices will be P1 multiplied with P2. This is by the definition of complete bipartite graph, which we have seen in our previous video lectures. So using that, we know that this will be equal to the cardinality of G1 union G2 plus the cardinality of the H set of K of P1 comma P2, and that is equal to, we know that H set of G1 union G2, we have already seen this, which is Q1 plus Q2 from first subdivision, plus what about this, just now I told you it is P1 multiplied with P2. Therefore we have proved that the number of lines for G1 plus G2 is Q1 plus Q2 plus P1 P2. Hence the graph G1 plus G2 has Q1 plus Q2 plus P1 P2 lines. Therefore we have proved the second subdivision. So if you see this, the proof of this subdivision is done. So next is the product. We can in fact call it as Cartesian product, or we can just call it as product of two graphs. So let us prove that the product of two graphs has P1 P2 points and the number of lines to be equal to Q1 P2 plus Q2 P1. So before seeing the theoretical proof, let us see the illustration for this by considering the same graphs that we had. So by definition of G1 cross G2, that is the Cartesian product of G1 and G2, is a graph having the vertex set of G1 cross G2 to be equal to the product of vertex set of G1 with the vertex set of G2. And when is when are 2 points adjacent in G1 cross G2, it is actually taken as ordered pair from the two graphs u1 comma u2, v1 comma v2, and these 2 points are adjacent if either u1 is equal to v1 and u2 is adjacent to v2, or u2 is equal to v2 and u1 is adjacent to v1. So you will understand this better when I explain with the example. So we will consider the same example, that is G1, where we have the graph u1 v1, and G2. What is G2? G2 is the graph this, that is u2 v2 and w2. Now we will take the product G1 product G2. We have to take the ordered pairs of these points first. So now if you see how you have to take the ordered pair, that is, first you take this u1 and take the ordered pair with all these vertices. So if you do that, it will be u1 with u2 first. So that point we will plot. So this is u1 u2. So this one is over. Next ordered pair is u1 v2. So that also you have to plot u1 v2. The next ordered pair is u1 w2. So u1 w2. So the ordered pair with this vertex with all these three vertices is done. Next you take this vertex and write the ordered pair v1 u2. So v1 comma u2. The next ordered pair is v1 comma v2. So v1 comma v2. The next ordered pair is v1 comma w2. So v1 comma w2. So now we have taken all the points. Now after this, what we have to do, we have to check, that is this condition, if u1 is equal to v1 and u2 is adjacent to v2 in G2, then here also those points will be adjacent. Or if u2 is equal to v2 and u1 is adjacent to v1, then here also those 2 points will be adjacent. That is, you check for this first. For example, these 2 points we will take. If you see u1, here also u1. So these 2 points are equal. So that equality condition we have got. So this u1, this is u1. Now we have to check whether u2 is adjacent to v2 in this graph. So if you check, u2 is adjacent to v2. So immediately you draw an edge between these 2 points. That means they are adjacent in this new graph also. So now you check with these 2 points, u1 v1, they are not equal, but u2 u2, these two are equal. If these two are equal, what we should do, we should check whether this pair is adjacent in this graph. What is this pair? u1 v1. Are they adjacent? u1 v1, yes, they are adjacent. So immediately here also they will be adjacent. Now these two pair we will check, u1 here v1, it's not equal, but v2, v2, they are equal. So if one of the vertices of the ordered pair is equal, then what we should do, we should check with the other pair whether they are adjacent here. So u1 v1, so if you see u1 v1 are adjacent, so here also they will be adjacent. Now check with this point and this point, u1 v2, this is u1 w2. So if you see u1 u1 they are equal, so check the other point v2 w2, are they adjacent here? v2 w2, yes, they are adjacent. So here also they will be adjacent, so draw the line. Now if you check these 2 points, u1 u2, u1 w2, so u1 u1 same, we have to check whether u2 and w2 are adjacent here. u2 and w2 are not adjacent, so there will be no line between these two. Now these two we will check, u1 v1, w2 w2, so w2 and w2 are equal. We have to check whether u1 is adjacent to v1, so u1 is adjacent to v1, yes. So here we have to draw a line. Now these 2 points if we check, v1 v1, so they are equal. So other check the other 2 points, v2 w2, are they adjacent here? v2 w2, yes, they are adjacent, so here also they will be adjacent. Now check this point and this point, v1 v1 equal. Here you have the u2 and here you have w2, so u2 and w2 are not adjacent, so there will be no line here. We will check these 2 points now. So v1 v1 equal, here u2 v2, so u2 v2, yes, they are adjacent, so here also they will be adjacent. So like this we should check and we have to draw the graph, and I have checked all the points with all the other points of ordered pairs, and this is the resulting graph. So therefore if we take a graph g1 g2 like this, then the product g1 with g2 will be like this. Now for this we know p1 is equal to 2 and q1 is equal to 1, and for this p1 is equal to 3 and p2 is equal to 3 and q2 is equal to 2. Now what does the theorem say? We have to check whether it has p1 p2 points. So what is p1 p2? It is the product of p1 and p2, that is 2 multiplied with p2 is 3. So that is equal to 3, 2 times is 6. So this is 6. We have to check whether we have 6 points here. 1, 2, 3, 4, 5, 6. So the number of points is equal to 6. So they are equal. Next, we have to check about the edges. So this one, that is q1 p2 plus q2 p1 we have to do. So q1 p2 plus q2 p1. We will check with this. What is q1? q1 is 1 multiplied with p2 is 3 plus q2 is 2 multiplied with p1 is 2. So what do we get? 3 1 times is 3 plus 2 times is 4. So we get 7. So are we having 7 edges here? 1, 2, 3, 4, 5, 6, 7. Yes, we have number of lines to be equal to 7. So therefore this theorem is proved with the help of this illustration. Now we shall prove this theoretically. So in order to prove this theoretically, by the definition we know that the vertex set of g1 cross g2 is equal to the product of the number of vertices of g1 with the number of vertices of g2. We know that the number of vertices of g1 is p1, it has to be multiplied with the number of vertices of g2 which is p2, therefore which is equal to p1 p2. Therefore we have proved that g1 cross g2, so g1 product of g1 and g2 has p1 p2 points. So this is done. Next we have to prove that g1 cross g2 has q1 p2 plus q2 p1 lines. So this is what we have to prove next. Now in order to prove this, let us take the point u1 comma u2, okay, to be an element of the product of the vertex set, that is v1 and v2. So the points adjacent to u1 comma u2, So what are the points that will be adjacent to this are, so first if you see, one of the point will be equal, so it can be adjacent to u1 comma v2. So where these 2 points are equal, so then what is the next condition? U2 should be adjacent to v2. So where u2 is adjacent to v2, so this is one. And what is the other point? If we take a point equal to this one, for example, if we take v1 u2, so these two are equal, u2 are equal, then u1 should be adjacent to v1. So where u1 is adjacent to v1, so these are the 2 points that will be adjacent to the point u1 comma u2. So what will be the degree of, so degree of u1 comma u2, it will be equal to degree of u1 plus the degree of u2. So with this we will get the degree of u1 comma u2. So now we are going to find the total number of lines for G1 cross G2. Now in order to find this, we are going to make use of the theorem that we have studied, that is the sum of all the degrees of Vi over I will be equal to twice the number of edges. Now using this theorem, we know that the number of edges will be equal to 1 by 2 of the sum of the degrees of Vi over I. So we will make use of this concept now. So actually we want to find the number of lines of, so number of lines for what? Of G1 cross G2. So this is what we want to find. And by using this concept, that will be equal to 1 by 2. Now here we have two parameters. So one is I, which is for graph G1, and the other parameter we will take as j, and this is for graph G2. So the vertices run from 1 to P1 and 1 to P2. And what about the degree? Degree of, if we take this as ui, and for the other graph we will take it as vi. So we have to add both the degrees. So ui and vi, where this ui belongs to the vertex set v1 of G, that is v1 represents the vertex set of G1, and vi is from v2, where v2 is the vertex set of the graph G2. So adding those two degrees and summing it up gives us the number of lines of G1 cross G2. Now we will take this summation into each of the terms separately. So first we will write this 1 by 2 as it is, and this summation we will have as it is first, I equal to 1 to P1, and we will take this one within the bracket. So it will be summation j equal to 1 to P2, the first is degree of ui, plus summation j equal to 1 to P2, degree of Vj. Okay, this is Vj. The summation is for j only. So this will be equal to 1 by 2 summation I equal to 1 to P1. And what about summation j equal to 1 to P2 of degree of ui? So this is degree of ui multiplied with P2. So it will be P2 multiplied with degree of ui, plus what about summation j equal to 1 to P2 degree of Vj? Again we have to make use of the theorem. We know that it is equal to twice the number of edges. So using that concept, here it will be equal to 2. And how many edges are there in graph G2? It has Q2 number of edges. So we should write 2Q2. So that is done. Now again we will take this summation within the bracket. So this will be equal to 1 by 2 of summation, this P2 we will take outside. So P2 summation I equal to 1 to P1 degree of ui, plus here we have summation I equal to 1 to P1 to Q2, and that is equal to 1 by 2. And what is this? P2 multiplied with, again the summation of the degree of ui will be twice the number of edges. And how many edges does the graph G1 have? Q1 number of edges. So it will be twice Q1, plus now 2Q2 we have, it is independent of I. So if you sum up with respect to I, this P1 will be multiplied with this. So we will get 2 P1 Q2. Now we can take this 2 common from both the terms. So 1 by 2 multiplied with 2, and within bracket we will have P2Q1 plus P1Q2. So this 2 will get cancelled, and therefore the number of lines, that is what we are finding, the number of lines of G1 cross G2 will be equal to P2Q1 plus P1Q2. Okay. So hence G1 cross G2 has Q1 P2 plus Q2 P1 lines. Therefore we are done with the third subdivision also. Now we are left out with the fourth subdivision, which will be proved in a similar manner of like we did the third subdivision. So we shall prove the fourth subdivision, that is composition of the graph G1 and G2 has P1 P2 points and P1 Q2 plus P2 square Q1 lines. Now in order to prove this, first we shall write the definition of the composition of two graphs. So by definition, the composition or the vertex set is same like product V1 cross V2. And when does the 2 points are said to be adjacent? So if we take points like this, then they are adjacent if one of the point is adjacent to the other, and or u1 is equal to v1 and u2 is adjacent to v2 in g2. So we will illustrate this first. So we will write the same illustration.